Find the probability of randomly drawing the given marbles from a bag of 6 red, 9 green, and 3 blue marbles. Without replacement, red, then red. So in this problem, we're going to be finding the probability of a red, then a red. So let's first go over what I put in a rectangle over here, without replacement. Now this is such an important word, without replacement. Take a note of this word because it's very important in this problem. This is going to determine whether we're dealing with independent events or dependent events. Now, independent events, an example of an independent event would be tossing a coin twice. Getting a heads on the first coin toss will not affect getting a heads or a tails on the second coin toss. In more general terms, the outcome of the first event does not affect the outcome of the second event. When we're dealing with dependent events, like we are here, the outcome of the first event will affect the outcome of the second event. So, when we're finding the probability of dependent events, we have to understand that we first find the probability of each of, I should have put a T there, each event, just put a T in there, of each event. So we first find the probability of each event, then we multiply the probabilities together. So let's first find the probability of getting a red. Now here I actually drew a picture of a bag. You don't have to do this. Sometimes it's good to actually visualize what's going on. If you are more of a visual learner when it comes to probability or when it comes to math, whatever. So if you need the picture, I drew it here for you in case you need it. So we're asked to first find the probability of getting a red. Now, we want to look in our bag or just look at the question. So there we have 6 red marbles in the bag. Now, remember that probability is just a likelihood that a given event will occur, and we can find the probability of an event using the ratio number of favorable outcomes. Let me just write this here. Number of favorable outcomes over number of total outcomes. So the number of favorable outcomes for getting a red is going to be 6, and the number of total outcomes is going to be 6 plus 9 plus 3, which should be 18. So we're going to have 6 over 18. Remember, we're going to first find the probability of each event. So the probability of getting a red marble is going to be 6 out of 18, because there are 6 marbles in the bag, and there are 18 total marbles. That's going to be multiplied by the probability of getting a red. So here's where it gets tricky, and here's where students make mistakes. They will say, well, the probability of getting a red is 6 over 18. That is true. The probability of getting a red is 6 over 18. However, since we are not replacing the marbles, if we take a red one out, and if we're drawing our hand back in to grab another marble, there are no longer 6 marbles in here. Because since one marble is gone, since we pick out one marble, there are now a total of 5 marbles. 1, 2, 3, 4, 5. There's no longer 6. So we have 5 for our number of favorable outcomes. Now, our total number of outcomes is not 18 anymore. Since there is 1 fewer marble in the bag, there's going to be a total of 17 marbles now. Remember, this marble doesn't count, so if you count these out, I'm not going to count them out, but there will be a total of 17 marbles. So now we have 6 over 18 times 5 over 17. Now I could multiply across the numerators and denominators, but I first noticed that, or you should first notice that 6 over 18 is not in lowest terms. So if we divide top and bottom by 6, the greatest common factor of 6, we get 1/3. So we can have 1/3 times 5 over 17. Now just multiply across the numerators and denominators, and we get 5 over 17 times 3. Well, 20 times 3 is 60. Subtract 9, we get 51. I'm just going to verify that just to make sure I'm not making a silly math mistake. 1, 2, 61. Oh, sorry. That should be, yep, sorry. That's 51. My mistake. 51. 3 times, yep. All right. So, if we carry that 2, we get 3 times 1 plus 2 is 5, so that's 51. Sorry about that, my mistake. So now we have 5 over 51. So the probability of getting a red marble and then a red is going to be 5 over 51. Now, if you wanted to, you could write that as a decimal. I'm just going to do it for you. So if we have 5 divided by, 5 divided by 51, that's going to be approximately 0.098 equals, I'll just write this down here, 0.098. To convert that to a percent, we move the decimal point 2 places to the right, and we have approximately 9.8%. So this would be your percent, this would be your fraction, they're all interchangeable. So the probability of getting a red marble would be 5 over 51. I hope this helped. If you have any questions, make sure to shoot me a message below. Thanks.